So here we are, again, doing evaluating limits day 2. Today's lesson will be a little bit more difficult than the previous lesson, just because we're taking things a little bit more in depth. So here we go. We are talking about evaluating limits still. And you'll notice that if I were to take the limit, I would do the direct substitution and plug in a 4. Unfortunately, when I plug in a 4, I get 0 over 0, which we know is indeterminate form. So we can't have indeterminate form. So now what we're going to do is we're going to try to rationalize the fraction. So we could rationalize the top or we could rationalize the bottom. In this case, since the radical is in the top, we're going to rationalize the top, otherwise known as the numerator. So we're going to multiply the top and the bottom by the conjugate. So we're going to multiply the top and the bottom by the square root of x plus 2 on the top and the bottom. When we do that, you should notice that I get x minus 4 on the top and x minus 4 on the bottom. Lucky for us, the x minus 4's cancel out, which is generally the idea. So if that doesn't happen, that generally means that you made a mistake and you want to go back and find it. So now I'm just left with 1 over the square root of x plus 2, where I can now do my direct substitution and plug the 4 in for x and evaluate my limit. When I do that, I evaluate my limit. I get the square root of 4, which is 2. So in the denominator, I end up with 1 over 4, well, the denominator is just 4, so I end up with 1 over 4, which is my limit. And I've done that by rationalizing. The same problem is the same idea. This time it's a little bit more difficult. We're going to rationalize. So we're going to rationalize by multiplying the top and the bottom by the conjugate. The conjugate is the square root of x plus 2 minus 2, the square root of 2. So I'm going to multiply the top and the bottom by that. So I'm going to have to FOIL. So when I FOIL, I'm going to end up with multiplying out, and I end up with x plus 2. The x plus 2 comes from this. And when I multiply the outside and the inside, they're going to cancel out because I have 2 times the square root of x plus 2, and then minus 2 times the square root of x plus 2. And then I end up with negative 4, well, the square root of 4, which is plain 2. So that gives me x plus 2 minus 2 all over x times that denominator. Now notice we did not multiply that out. We don't usually do that when we do these. It just saves us some time a little bit later, because when I do 2 minus 2, that's going to cancel out. So I'm going to be left with that x. Lucky for us, that x cancels out in the top and the bottom. So I'm just left with 1 over the square root of x plus 2 plus the square root of 2, which I can do my direct substitution with. When I do my direct substitution, I just get the square root of 4 plus, the square root of 4 plus 2. And when I do that, I just get 1 over 2 plus the square root of 2, which again, we would need to rationalize and simplify that fraction. But at that point, that's much easier than what we had before. And then here's the next situation where I could have something where I have a fraction. If I do, and again, always the first choice is to do the direct substitution. When I do the direct substitution, though, I still get indeterminate form of 0 over 0, so that means I need to do something else. So we have a complex fraction, so we're going to get a common denominator in the numerator. So our common denominator is 4 times x plus 4. The first fraction needs a 4 in the top and the bottom, and the bottom fraction needs, the second fraction needs an x plus 4 in the top and the bottom. When I put them into one fraction, I'm left with 4 minus x minus 4. Don't forget to distribute that negative sign right here to the 4. And then I can combine like terms, and I'm left with the 4's canceling out. So I'm left with negative x over 4 times the quantity of x plus 4. And then I can take this x that's down here, and then remember that's x over 1. Since I'm dividing, I can flip it and make it 1 over x. So then I'm left with the x's cancel out. And I'm left with negative 1 over 4 times x plus 4, which I can then do my direct substitution. Remember, we're taking the limit as x approaches 4, or sorry, as x approaches 0. So I'm left with 0 plus 4, which is just negative 1 over 16. I have the same basic idea with this problem. Again, if I do the direct substitution, I still get 0 over 0, which chances are when I'm giving you a problem like this, that's going to happen because I want to see what you can do. So we get a common denominator in the numerator, which we do up here. And then we're going to distribute that negative. which gives us 2 minus 2 minus x, all over 2 times the quantity of 2 plus x over x. I can then cross those out, and I'm left with negative x. I can flip the bottom fraction there to make it 1 over x. The x's cancel out, and I'm left with negative 1 over 2 times the quantity of 2 plus x, which then I can do my direct substitution, and I'm left with negative 1/4 as my limit. It takes a little bit of time and a little bit of getting used to doing those problems like that, but after you've done a couple of them, they kind of get to be the same thing over and over again. So it's pretty easy. Then I can have the limits of a power function at infinity. Whenever I have something that's raised to a power, like an x raised to a power, and n is the limit is approaching infinity, it's just going to keep getting larger and larger and larger. If it keeps getting larger and larger, that means my limit is going to be infinity. So that's what you find when you have something like that. Now, if you're taking it as x approaches negative infinity, though, then it's going to be a little bit different. If n is even, meaning the exponent is even, we know that it's going to be going up, both like that, on the left and the right. So that tells me that it will go to positive infinity. Remember our n behavior when we talked about that earlier in the year and last year. If n is odd, we know that as x gets bigger and bigger, that it's going to go up on the right and down on the left. But we're going for negative infinity. So since it's going down and I want to know what x is going to happen as x goes to negative infinity, my answer is going to be negative infinity. So we're going to use those in a problem when we start talking about polynomials. So here I have a big long function, and it's got a whole bunch of different parts. This one has a part, and who knows however many different pieces they're going to be there. When I have all those different pieces, the only one that's really important to me is the highest exponent. So I'm going to look at the one that has the highest exponent. So let's look at an example because I think it's going to make it a little more clear. If I look at a problem like this, I'm going to find my highest exponent that's in my problem. So that's this one. So that's the only piece that I'm really going to be concerned about, because if I add all these other ones to it, they're going to be infinity anyways. So it really doesn't matter if I add a little more infinity to infinity, I'm still going to have infinity. So I have 2x to the fourth, which is what my highest exponent is. If x goes to negative infinity, we're talking about being an even power. So since it's an even power, 2 times infinity is just going to be infinity. So that means that my answer is going to be infinity. If I have something like this, again, I'm going to look at the highest exponent. My highest exponent is x to the fifth. Since x is going to negative infinity and it's an odd power, that means that my limit will be negative infinity. Because remember, since it's an odd power, it will go down on the left and up on the right. And the down on the left is what we're concerned about as x goes to negative infinity. So that's why my answer is just negative infinity. And I have this problem. Now I'm going to positive infinity. If I'm going to positive infinity, I'm going to look at the highest power. The highest power is x to the third. X to the third, if I put in an infinity and cube it, I'm still going to get infinity. So my answer is just going to be infinity. Now we can start talking about having something where I have a fraction. And if I have a fraction, I'm going to take something like 1 over infinity or 1 over negative infinity. Whenever I do 1 divided by infinity or 1 divided by negative infinity, my limit is going to be 0. And that can be shown by these two graphs here. If I have 1 over x or 1 over x as I go to the right to positive infinity out this way, it's going to go to 0. And if I go to the left, for negative infinity, it's also going to go towards 0. So that's going to be my limit whenever I'm dividing by infinity. So if I have an equation that looks like this, we did something like this before when we were talking about finding asymptotes. So x is going to go to negative infinity. So what I'm going to do is I'm going to pick the highest exponent. So the highest exponent that's in this entire problem, the numerator and the denominator, is x. So I'm going to divide every term by x. So I have 2x divided by x plus 1 over x, because I'm going to divide every term by x, and then the 3 is going to be divided by x, and then the 4 is going to be divided by x. Anytime it has something with an x in the denominator and it's going towards either infinity or negative infinity, it becomes 0. So that up there is a 0, and that down there is a 0. So when I take my limit, I'm just left with 2 over 3. So that means that's going to be my limit. and it goes a little bit more in depth here, but then we end up with 2 over 3, which can also be shown if I look at the graph. As x goes to infinity, negative infinity, the graph goes to 2/3. I'm going to do the same thing for this problem. So I'm going to find my highest exponent. So the highest exponent is x cubed. So I'm going to divide everything by x cubed. When I do that, some things cancel out. So I'm left with just 2 minus 1 over x over 3 over x minus 1 over x cubed. So then when I look at that, I can see that obviously anything that has an x in it is going to go to 0. So that's going to go to 0, and that's going to go to 0, and that's going to go to 0. So now I'm going to end up with 2 over 0. So when I have something that's 2 over 0, I can't really divide by 0. So that means that I have, as you're reading here, we know that 2 over 0 is getting larger and larger and larger, so therefore our limit is in fact approaching infinity. I'll wait a little bit for you to read. And here's our next problem. Next problem, we're going to find our highest exponent is cubed, so we're going to divide everything by x cubed. And then you can see that I can start crossing things out, because I'm going to end up with that going to 0, and 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 that going to 0. So when I do that, I'm only left with 2 things. So that means my limit is going to be 5/2. And that's all we have. So hopefully you can understand a little bit of what we're doing. All we did was we simplified fractions by finding a common denominator in the numerator and the denominator and simplifying the fractions that way. We also rationalized functions in order to find the limit. And then the last thing we did was we took limits as x approaches infinity. Hopefully it was easy to understand, and we'll talk about it tomorrow. Good night.